Hi all of you. Today we will start with our next topic, pin diagram of 8086. In the previous lecture we have studied architecture of the 8086 as well as the organization, that is the register organization of 8086. So let's start with the pin diagram of 8086. So before going to the lecture I will discuss some basic things, so that I already explained you so many times, but still some revision. So Intel 8086. So 8086 is nothing but the Intel processor, and it was launched in 1978. It was the first 16-bit microprocessor that we have already discussed many times. This microprocessor had a major improvement over the execution speed of 8086. So I will explain you how it is. So actually 8085 is not containing the pipelining structure, okay, but 8086 is having the pipelining structure. Means what? So at a time the instruction is fetched, and at the same time we are executing the instruction, okay. So there is a time save, so we can increase the speed of execution of the instruction and we can process the things faster. This in 8085 we can first execute the instruction, okay. After execution of that, then we can fetch another instruction, okay. After execution of that instruction, we are fetching another instruction. So this is nothing but the time consuming process. So this is the best improvement, that is nothing but the execution of the speed. Now it is available in 14 pins, that is a dual inline package, that is called as a DIP, okay. So next, Intel 8086, it is a variable in three versions. So 5 megahertz, okay, 8086 to 8 megahertz, 80861 10 megahertz, and it consists of almost 29,000 transistors, okay. It is made up of the 29,000 transistors. So this is nothing but the execution speed, this megahertz, this is nothing but the speed of your processor. Now, so 8086 we know all, this is nothing but the 16 bit is the data line, or you can say the data bus. 20 line or 20 bit is the address bus. So it could address up to 1 MB of the memory, okay. So you can fetch the address of the almost up to 1 MB of the memory. So it has more than 20 instructions, okay. It has more than 20,000 instructions, okay. So it supports multiplications and divisions as well, so in the ALU unit. So now let's start with our main topic, that is a pin diagram of Intel 8086. Now you can see here, so how many pins are you looking into the diagram? Yes, 14 pins, okay. So 40 pins are there. So you can see here, just a minute, I will come to the some graphical interface. So you can see here, so first we'll go for the 14 pin, okay. The 14 pin is VCC, okay. So 40 pin is a VCC. First, for driving any circuit or any microprocessor, there is a supply is needed, okay. So that's why I am discussing this, okay. Without supply we cannot work any electronics thing, we cannot work without a supply. So this VCC, that is a 40 number pin, it contains the 5-volt supply to the processor, okay. So this is very important first. So VCC, we are providing the plus 5-volt supply, and now similarly with combined with the 5-volt VCC, there is a VSS, or we can call it as a ground, okay. So here is the 20 number pin and pin number 1. So both are having the ground, okay. So you can connect the ground any of the pin between 1 and 20. So there is a VCC and VSS ground, okay. So now you can see here, so you can see here, so AD01 to AD14, okay. So you can see here from AD01 to AD14, and AD15 pin is here. So what it indicate exactly? So actually that is called as, okay, that is called the, just a minute, that is called the address and data bus, okay. That is called address and data bus. So these are low order address bus and they are multiplexed with data, okay. That is nothing called as a multiplexed data bus, okay, or you can say the multiplexed line. Why it is? Because it is carrying the data as well as address, okay. It is carrying data as well as address. That is why A for stand for address and D for data. So that is why it is combinedly called as AD. So AD0 to AD15. Now you can tell me the data bus is how much bits? It is 16 bits, right? So from AD0 to AD15, okay, so from here AD0 to AD15, it is carrying the data. Okay, it is nothing but almost total there are 16 bits. So how much it carrying the data bus? That's why from AD0 to AD15 it is called as a data bus. Okay, now you can see here there are more A16, A17 and A19. Sorry, A18, A19. So now you tell me how much is the address bus? Yes, 20 bits. Okay, so this 20 bits, how exactly this come from? Now, so this AD15, okay, from AD0 to AD15, that is 16, okay, plus this A16, A17, A18 and A19 plus 4, that is total 20 bits of address bus. So at the same time, this AD0 to AD15, that is we can combinely, or we can say the common pins that can carry the address and the data as well as. Okay, so when the data are transmitted over AD lines, the symbol D is used in place of AD. Okay, when there is a carrying the data in this line, so only symbol D is used. For example, D0 to D7, D8 to D15 or D0 to D15. Okay, so when we are carrying the only data, when we are carrying only data, then the symbol is only used D0, D1, right? Now there is A16, A19, these are called as a high order address bus. These are multiplexed with the status single. So A16 to A19. Okay. Now we are moving towards the next pin, that is nothing but NMI. You can see in the NMI pin number 17. Have you found it? NMI. Here is NMI. That is nothing but pin number 17. That is called as a non-maskable interrupt. That is called non-maskable interrupt. So what is meant by this non-maskable interrupt? This is an edge triggered input which results in a type 2 interrupt. Okay, when the programming will come into the picture, then you will understand exactly what is the interrupt and all these things. The interrupt is nothing but what? Suppose in execution of the program, is there any interrupt is arrived? Okay, so interrupt means some problem is there, so this causes or it this bit will get high. Okay, so a subroutine is then vectored through the interrupt vector lookup table which is located in the system memory. So NMI is a non-maskable internally by software. Now software, by what is mean by this? This non-maskable interrupt cannot handled by the programmer. Okay, suppose I am a programmer and if then an interrupt is occur, so I cannot handle that interrupt. So even the system itself can handle that interrupt. Okay, so how exactly a transition mode from, suppose there is a low 0 to low high, it initiate the interrupt at the end of the current transition. Okay, current instruction. So if NMI is 1, okay, this bit set 1, so it means what? If it bit set 1, it means what? So there is a interrupt. Okay, so this is nothing but the active high. So I will first understand what is active high and active low. Okay, so I will forgot to explain in the starting of the lecture. So you can see in the some of the instruction, some of the pin diagram, there is a notation written by the bar. Okay, and some are not written in the bar. So those are not written with the bar. Okay, so they are simply, suppose NMI. So in NMI there is no bar. Okay, so there is no bar here. So what is meant by this? This is active high. Okay, means active high means what? So in 1 and 0, when active high means this bit set to 1 when it is a active. Okay, means suppose there is a interrupt, then it will become 1, otherwise in the normal condition it remains 0. Okay, that's why it is called as a active high. Now you can see here BHE. Okay, here pin number 14, I will just explain, that is a bar. Okay, so BHE is having the bar, means what? It is active low. Okay, when this bit is 0, then this 34 pin number is active. So that is nothing but active low. That is called when that bit is set 0, then it become active. I hope you understand what I am saying. So come to the picture again. So come to our topic. So NMI, that is a non-maskable interrupt. That's interrupt cannot handle by the programmer. So system itself can handle that interrupt. Okay, so there pin number 18. Now you can see INTR, that is pin number 18. So this pin number 18, that is nothing but the interrupt knowledge. It active low 0 during the during the interrupt in the acknowledged cycle. Means suppose there is some instruction is going on and then there is a interrupt. So the programmer can handle that interrupt. Okay, so that is called as a normal interrupt. Now the next, that is a pin number 19, that is a clock. Okay, pin number 19, that is a clock. Now I will tell you what is the, this clock is very important now. So clock input, the clock input provides the basic timing for a processing the operation and bus control activity. It is an symmetric square wave with the 33% of the duty cycle. So when we perform the programming, then I will understand, or I will explain what is the timing diagram and all these things. So first, this clock is used for the synchronization purpose as well as for the processing or timing for the processing the operation. Okay, suppose means what? So most of the time what happen, suppose if you want to synchronize between the receiver and transmitter, or you can say in the processor, so this clock is also used. Okay, so now we are moving towards the next, that is, now we have explained already the pin number 20, that is the ground. So next is, just a minute, next, now we are coming to the pin number now 40, that is used as a VCC. So pin number 40, it is used as VCC. 39, that is nothing but the data and address, that is combinedly A and D. So 38 and 37, 36 and 35. Suppose now you can see there, suppose there is a S3 and S4. So you can see oblique A16 oblique S3 and A17 oblique S4, that is pin number 38 and pin number 37. Okay, so how exactly it works? So S3 and S4. So what it can be used, that bits can be used combinedly. I will explain you all the things again in the coming slides in the written. So but I am explaining, or I am taking the overview here. So S3 and S4, so that is nothing but 0 0 0 1, then 1 0 and 1 1. Okay, so this is S3 and S4. So this is nothing but the bit set like a 0 0 1 1 and 0 1 0 1. Now you can see, or you can go into the architecture. If you learn the last, if you have gone to the last videos, architecture of the microprocessor, there is a one segment or address bit or address segment into the BIU unit, that is a CS, that is a code segment, extra segment, data segment, and that is stack segment. So there are 4 segments. Though if you want to access that segment, this S3 and S4 can be used. Okay, so how it can be used now? Suppose S3 and S4 are 0 0. Okay, S3 and S4 and 0 and 0, that is a ES. Okay, extra segment is used. When you want to use the extra segment, or you want to access the extra segment, then you can set this S4 and S5 0 0. Okay, now if you want to access stack segment, okay, if you want to access the stack segment, you can set S3 0 and S1 1, S4 1. Okay, if you want to access the stack segment, then you can set S3 0 and S4 1. Now if you want to access the code segment, okay, this is the code segment of the, this code segment contain the address of the your code memory or instructions memory. Okay, so 1 and 0 if you set, then you can access the code segment. And now the last one is a DS. If you set 1 1, both the S3 and S4, you set 1 1, then you can access what? You can access the data segment. Right, I hope you understand what is the use of S3 and S4. Okay, so now we are moving towards the next, that is the next is the BHI, sorry, BHE. BHE, that is nothing but, just a minute, BHE is the, okay, so this BHE can be used in bus high enable status. So bus high enable, so BHE stand for bus high enable. When it is a bus high enable, when it is 0, because the bar is there in on is top. Okay, so there is a bar, so BHE stand for, or BHE can be a bus high enable. So when it is a 0, then it is a high. So how it can be used? So sometime you have to use only a lower upper bits or lower bits. Okay, so when you are going to use the upper bits, so BHE and 7S. Okay, so BHE and 7S, so that is nothing but also the set of the bits. So 0 0, that is 0 1 1 0 and 1 1. when you are going to use the upper bits, okay, when you are going to just a minute, let me check. When you are using the BHES1 and both are 00, okay, then it can be a whole width of the that data bus can be used. So total 16 bits can be used. When there is a 01, so you can use the upper bits. Okay, upper bits means from D8 or D7 to D15. Sorry, D8 to D15, right? When n and 0, 1 and 0, then you can use the lower bit, that is D0 to D7. And if you are using the none, then you can set this bit 1 and 1. Okay, so this is how exactly the pin diagram. Then I will explain you each and every in the written form also. So there is one more few points are remaining, mean and max. So I will take another lecture on this minimum and maximum mode. So from pin number 24, okay, to pin number 31, that is come under minimum and maximum mode. So that is another lecture, I will explain in the next lecture. So we will discuss this pins later. So min and max means what? When you are using the microprocessor in a minimum mode, then that bit should be a 1, because mn is not having the bar. And when you are using this processor in a maximum mode, then mx is a, or this bit set to 0, because mx is having the bar. I hope you understand. For minimum, bit is 1, and for maximum mode, bit is 0. Now there is, we are going into the pin number now 23, that is a test. Okay, so what exactly test? So this is examined by the wait instruction. If the test pin goes low, execution will continue. Okay, suppose there is a, if you want to wait, then you can set this test pin is a 0. Okay, so for this examined by the wait instruction, if the test pin goes low, execution will continue, else the processor remains in the ideal state. So this, the input is internally synchronized during the each of the clock cycle on a leading edge of the clock. Now the next ready. Now this ready is used. Now next pin number 22, this ready pin is used. This is the acknowledgement from the memory or slow device that they have completed the data transfer, and the signal made available by the device is synchronized by the 8084 a clock generator to provide the ready input to the microprocessor. Means, suppose if you want to execution, if you want to transfer the data, then this ready bit set 1, then it should indicate that my microprocessor is ready for the processing. Okay, so that is how the ready. Now reset. So reset is when, if you want to reset all the settings, that is very simple. So resetting means what? So whatever the pins modes you have set, if you want to reset them, then you can use this reset. So you can see most of the processors that is having one small top or small button. If you press it, then your processor will get reset. So this pin requires the microprocessor to terminate its present activity immediately, and the signal must go active high for all least 4 clock cycles. Means what? Suppose there is execution is there is any instruction is processing, and if you want to debar that execution, or you want to cancel that execution, then you can press the reset. Now we are explaining. I hope you understand all the pins. Now I will explain you this by using some diagrams. Okay, so I have separated it also. So I will just read it because I have already explained you all the things. So AD0 and AD7. So this is nothing but these are lines are multiplexed bidirectional address data bus. Okay, so during T1 they carry lower order 16-bit address. In the remaining clock cycle they carry 16-bit data. So AD0 to AD7 carry lower order byte of the data, and AD8 to AD15 carrying higher order of byte of the data. So at the what time? So in the T1 they carry lower order 16-bit address, and in the remaining clock cycle they carry the 16-bit data. So both AD and both the AD can be carry data and address. Okay, so that is called as a bidirectional. Now A19, A18, A17 and A14, so these are nothing but what? These are multiplexed unidirectional address and status bus. Okay, so during T1 they are carrying only 4-bit address. In the remaining clock cycle they carry a status signal. So in the first during T1 cycle it carries the address, and the remaining timing it carries the status signal. So different flag generated status signal. So it carries the different status of the microprocessor. Now BHE and S7, this is also very important pin. So BHE stand for bus high enable. Okay, so I already explain you. So BHE signal is used to indicate the transfer of the data over higher order data bus D8 to D15. So 8-bit input output devices use this signal. So it is multiplexed with status pin S7. Okay, this is multiplexed with status pin number S7. So how it is, that I explain you, that is, so when that is a 0 0, both BHE and S7 is 0 0, it carries what? It carries the whole bit, or you can use the whole bit of the data bus. Suppose there is a 1 0, it carries the lower, this is 1 0, 0 1, that is upper bits, and if there is a 1 1, that is a 0, means not is performing, it is not performing any operation. Now read, so it is read the signal used for read operation. So it is an output signal. So pin number 32, it is nothing but the read signal. So it is active low. When it is active low, means that is bit is 0, then it is reading the signals. Okay. Now ready. So this is an acknowledgement signal from slower input output device or memory. When it is an active high signal, okay, it is a active high signal. When it is a bit, means active high means suppose 22 bit is 1, set 1, it indicates that the device is ready to transfer the data. When low, then microprocessor is in a wait state. Okay, if you want to wait, if you have to wait. Now reset. So it is also system reset. It is an active high signal. Okay, it is active high signal, means what? So 21 number bit is set 1 when the microprocessor enters into the reset state and terminate the current activity. So whatever the current activity is going on, it simply terminate it and comes into the reset mode. So it must be active for at least 4 clock cycle to reset the microprocessor. So we have this reset button should be active almost for the 4 clock cycles. Okay. Now INTR, so that is nothing but the interrupt request signal. So it is active high and it is level triggered. Okay, did I explain you? Now NMI, there is a non-maskable interrupt signal. It is an active high and it is an edge triggered interrupt. Okay, so now I hope you understand level triggered and edge trigger in the digital system or digital electronics. So level trigger means, suppose there is a clock signal. I will explain you what is exactly. Suppose there is a clock is like this. Now what is the level trigger? Means when this comes to the here, okay, at this level, then it get triggered. When the interrupt it triggered, means when there is a interrupt enters. Okay. Now what is the edge trigger? Now you can see here, this NMI is the edge trigger, means what? When it is in the rising edge, okay, might be it is in a rising edge or in a following edge. When this going from here to here, then that interrupt is triggered. Okay, so that is the difference between level triggered and edge triggered. So test, it is used to test the status of math coprocessor 8087. So the busy pin of 8087 is connected to this pin of 8086. So it is a execution continue, else microprocessor is in a wait state. Suppose it is a test mode is 0. Okay, so if you want to test the microprocessor in a wait state or a busy state. Now the clock input provides the basic timing for a processor's operation. So it is symmetric square wave with the 33% of the duty cycle. It has range up to 5 megahertz, 8 megahertz and 10 megahertz. It gives the execution of the speed. So how much the speed or how much the data or instructions can be proceed, it depends on this clock. Now VCC and VSS, that is nothing but the power supply and ground. So I will explain you in the starting slides. Now MN and MX, so I am going to take an extra lecture on this MN and MX. So this pin number 34, okay, so pin number 34 to 31, these are nothing but what? So these are nothing but the MX and MN. So this, if I, this bits, so this is nothing but the minimum mode pin and these are nothing but the maximum. Okay, so when the MN bit set 1, okay, it works in a minimum mode, and when MN or MX bar set is a 0, it works in a maximum mode. Okay, so in the next lecture I will explain you this. This is required more half hour. So pin number 24 to 23 issued two different sets of signals. So one set of signals is issued with the CPU operated in a minimum mode, and another set of the signals issued the CPU operates in a maximum mode. So thank you very much for have a nice day, have a nice day. So if you have any queries in the pin diagram, you can simply call me or message me. So thank you very much for today's lecture.